Morning, Dr. Maya. Today, my partner and I come from Group 2, number 10. I'm going to present our project, which is titled to design a 4-bit down count counter with red LED. So, what is a counter? For my understanding, there are different types of counter. There is up counter, down counter, and bi-directional counter. So in our project, we are going to design a 4-bit down counter. A 4-bit down counter function is like to count down the binary number from 15 to 0 when the clock input trigger the stage, then the output will change. So now I will pass to my partner to discuss our coding. How the 4-bit down counter to function. So, Sun.
Okay, Dr. Mayam, now let me explain to you what is our coding. And our coding includes two parts. One is the main counter part, and another part of coding is the clock counter or the frequency divider.
Sun.
So you can see in the coding, the module counter will assign clock and clear as the input and 4-bit output out. And one more TMP is assigned as temporary memory for the output. This wire clock 1 Hz is come from the frequency divider or the clock counter. You can see in the clock counter coding, we also assign clock and reset. But our main function of this Verilog coding of slow clock is to generate a 1 Hz clock. So you can see in the coding, always block positive edge clear clock. So you can see inside, when counter count to 25 mega times, the counter will plus 1. Why? This is because FPGA board will count 50 megahertz times. That means in a clock pulse, it will count 50 mega times, then our counter will plus 1. So you can see from this is 50 megahertz times. So now our clock pulse will generate once only. This is our clock for using to the counter. Then go back to the coding. So now you understand why we use 25 mega times for our counter to plus 1. This is to generate a full wave of a 1 Hz clock pulse. So go back there. In the always block of our counter, we assign clock as positive edge and clear as negative edge. So when our clear equals to 0, our output will straight away clear to 1111 as the original. Else, our output will continue counting for down counter when the clock trigger once. Every second will trigger 1 times. This is all about our coding. That's all.
Okay, thank you, my partner. So now I'm going to discuss about the board, the operation of our counter. So this is our data board, the function. The function, we assign the 4-bit output to the 4 red LED, from red LED 0 to red LED 3. 0, 1, 2, 3. And we set the clear button, or we call it reset button, on the push button 0. So now the operation of the down counter will run from the descending number from the most significant bit down to the least significant bit. We assign the most significant bit number to red LED 0, red LED 3, and the least significant bit to the red LED 0. So now let us see about the function. Now we reset 15, 14, 13, 12, 11, 10, 8, 7, okay, so this is a cycle from the most significant bit 15 to the least significant bit 0. Now we try to reset it. So it will repeat again from the 15 binary number 15 and count down to the 0, 0, 0. So that's all for me. That is about the coding and the hardware implementation for our project. So that's all for us about the project for big dump counter. So thank you.